For 2,000 years, sea power meant the same thing: steel, tonnage, and the sailors who carried a nation into harm's way. The bigger the fleet, the greater the power. On the 12th of July, 2026, that equation quietly broke. In the dark, in a crowded enemy harbor, without a single human being on board. 3 uncrewed surface vessels struck Bandar Abbas. An uncrewed surface vessel, a USV, is exactly what it sounds like: a robotic boat. No crew, no bridge, no one to lose. These 3 navigated entirely on their own. They autonomously picked their way through the shallow, cluttered harbor waters, threading past fishing craft, buoys, and moored hulls that would challenge an experienced human helmsman. And then, they detonated high-explosive payloads against a docked Iranian Ghadir-class midget submarine. U.S. Central Command announced the operation the following day. Buried in the careful language of that statement was a genuine turning point. This was the first operational strike by American one-way attack sea drones, machines built not to come home, but to deliver a warhead and be spent. In military terms, they are attritable, cheap enough and numerous enough that losing them is simply part of the plan. The vessels were Corsair-class drones, made by a defense startup called Saronic Technologies. And Saronic is not a century-old shipbuilder. It was founded in Austin, Texas in September 2022, closer to a Silicon Valley software company than to a traditional naval yard. In just over 3 years, that startup reached a valuation of $9.25 billion, raising more than $2 billion from investors betting that the future of naval warfare would be built in a factory, not a shipyard. So what exactly did they build? The Corsair measures 24 feet in length, small, low, and hard to see. It features a diesel-powered jet propulsion system with no exposed propellers. That single design choice does 2 things at once. It prevents debris fouling, no propeller to tangle in nets, rope, or seaweed in a cluttered harbor, and it reduces the vessel's acoustic signature, making it far quieter to the sonar operators hunting for it. The craft exceeds 35 knots, with an endurance of over 1,000 miles, meaning it can be launched far from its target and loiter for days. And it carries a versatile 1,000-pound modular payload bay, a bay that can hold sensors, cargo, or, as the world would learn, high explosives. That word, modular, is the whole story. Because just 5 weeks earlier, the same platform type executed a very different mission. On June 8, 2026, an Army AH-64 Apache helicopter crashed into the sea near Oman. In the water, at night, a downed aircrew has minutes, not hours. Task Force 59, the Navy's unmanned systems task force in the region, diverted a nearby Corsair that was quietly doing maritime surveillance. Using only passive sensors, emitting nothing that could give away its position, the drone located the downed aviators in the dark. It came alongside. The pilots pulled themselves onto the drone's low, flat hull, and the autonomous vessel carried both men safely out of danger. No rescue crew was ever put at risk. A robot boat had just saved 2 American lives. 34 days later, 3 Corsairs executed a lethal kamikaze attack. This is the part that should stop you. The very same class of vessel that had cradled 2 rescued pilots was now a weapon, and nothing physical had to change. Reconfigured software transformed the rescue craft into a precision weapon. A rescue platform became a guided missile with a software update. The target was an Iranian Ghadir-class submarine, resting on a maintenance hoist, lifted out of the water and utterly exposed. Striking the submarine destroyed both the vessel and its vital repair equipment, taking out not just a boat, but the infrastructure needed to fix the next one. None of this works without the intelligence running underneath it. Corsairs run on an autonomous software stack called Echelon. Echelon is the reason a handful of sailors can wage a campaign that once required entire crews. It allows a single operator to command dozens of autonomous assets simultaneously. A human on the loop, setting intent while the machines handle the second-to-second work. Onboard edge computing processes sensor data locally on the vessel itself, without human intervention and without waiting on a satellite link. Phased array radar, computer vision, and infrared sensors guide the vessel, fusing a picture of the battle space in real time. And critically, if satellite signals are jammed, the first thing any modern adversary will try, internal algorithms maintain the attack mission. The drone does not go blind. It keeps going. Integrated swarm logic then lets multiple vessels coordinate simultaneous strike angles, boxing in a target from directions no single crewed ship could cover at once. Now step back, because the operation proves a major shift in modern naval cost dynamics, and this is the part that keeps admirals awake at night. For decades, the math of naval defense has run backwards. Legacy navies spend millions using interceptor missiles against cheap targets, firing a $2 million missile to knock down a $2,000 drone. Do that enough times, and you lose, even when you win every engagement. Saronic flips the equation. Each Corsair costs roughly $1.2 million to manufacture, a rounding error against the price of the warship, submarine, or aircraft carrier it can threaten. Destroying an irreplaceable submarine with a fraction of its value achieves a deeply favorable cost-exchange ratio. Attack with something cheap, destroy something priceless. In the Black Sea, Ukraine, a nation with almost no traditional navy, had already shown the world what cheap, uncrewed boats can do, using drones costing a tiny fraction of a warship to damage or sink a large share of Russia's Black Sea fleet and drive billion-dollar vessels back into port. The Pentagon was watching. In 2023, it launched an initiative called Replicator, a crash program to field thousands of small, attritable, autonomous systems across every domain. An explicit bet that mass and software, not exquisite hardware, would define the next war at sea. Which is why the money is now following the machines. The Navy awarded Saronic a $392 million contract. And Saronic is constructing Port Alpha, a giant shipyard in Brownsville, Texas, built from the ground up for autonomy. The $3.2 billion facility covers 835 acres, and it is designed to do to warships what modern factories did to cars and consumer electronics. Port Alpha will mass-produce software-defined autonomous warships for the fleet, not by the dozen, but at industrial scale. And that is the real revolution. Not one strike in one harbor, but a boat whose mission is written in code, built on an assembly line, and cheap enough to lose by the hundreds. It raises hard questions, too, about escalation, about machines making the first move, about how you defend against a weapon that costs less than the missile you'd fire to stop it. Those debates are only beginning, but the direction is no longer in doubt. Maritime combat has officially shifted into the age of algorithmic warfare, and the sea will never be the same. If you enjoyed the video, please like and subscribe. Birds of Firm, out.